Good day everyone, I am Jeryme Mina from BSE 2B Mathematics and I'm your instructor. Our topic for today is about Euler's Theorem. But before we start, I want to share some of contribution of Leonhard Euler's in the field of mathematics. Leonhard Euler was a mathematician, astronomer, geographer, logician, and engineer who founded the studies of graph theory and topology. He was born on April 15, 1707 in Basel, Switzerland, and he died on September 18, 1783. Now let's move on to our topic, Euler's Theorem. In the number theory, Euler's Theorem, also known as the Fermat-Euler Theorem or Euler's Totient Theorem, states that if n and a are comprised positive integers and is Euler's totient function, then a raised to the power is congruent to a 1 modulo n. But before we proceed, I want to tell to all of you that Euler's theorem has 4 rules. So, what are the 4 rules? So, rule number 1, p minus 1, where p is a prime. Rule number 2, p raised to n minus p raised to n minus 1, n is a prime power. Rule number 3, quotient of m times the quotient of n. Rule number 4, or the last rule, is the most applicable rule, and that is the rule number 4. So, n times the quantity of 1 minus 1 divided by or over to p sub 1 times the quantity of 1 minus 1 divided by p sub 2 times the quantity of 1 minus 1 divided by p sub k. So, for better understanding for this lesson, let's give some example. Let's say 11 raised to 101 mode 21. The first thing we need to do is to get the factor 21. The factor of 21 is 3 and 7. Because 3 and 7 are prime number, so we use the rule number 4. So, which is n times the quantity of 1 minus 1 divided by p sub 1 times the quantity of 1 minus 1 divided by p sub 2 times the quantity of 1 is minus 1 divided by p sub k. Now, let's substitute the given variables. So, we have 21 times the quantity of 1 minus 1 divided by 3 times the quantity of 1 minus 1 over or divided by 7. As you can see, we use the denominator 3 and 7 because 3 and 7 are the factor of 21. After that, let's proceed and we need to simplify. So, 21 times the quantity of 2 divided by 3 times the quantity of 6 divided by 7. So, the answer is quotient 12. Now, let's have a quotient 12. Let's use it. 11 raised to 12 or 11 raised to the 12 power congruent to 1 mode 21. After that, we need to divide 109 to 12. So, which is 9. So, 11 raised to 12 power, or the quantity of 11 raised to 12 power and raised to 9 times 11 congruent to 1 multiply 11. Because 109 divided by 12 is have a remainder. So, multiply the raised 11 to the 1 power. congruent to 1 times 11. So now, let's get the answer congruent 11 and mode 21 or mode 21. And that is the example for Euler's theorem regarding the fourth rule. Now, let's try another example. Let's say we have 13 raised to 193 power, mod 35. First thing we need to do is to factor 35. So the factor of 35 is 5 and 7. Because that factor, we use rule number 3. So which is the quotient of n times the quotient n. Now let's substitute the given value. Quotient 5 multiplied by quotient 7. After that, we need to apply rule number 1 to solve easily. So quotient 5 minus 1 multiplied by quotient 7 minus 1 is equal to quotient 4 and quotient 6. The answer, it will become quotient of 24 because we have quotient 24. Let's use it. 13 raised to 24 power congruent to 1 mod 35. We need to divide 193 to 24 and it will become 13 raised to 24 raised to 8 times or multiply 13 raised to 1 and congruent of 1 multiplied by 13 because 193 divided by 24 is equal to 8 and they are remainder, so let's put it. So the answer is congruent 13 and 35. Thanks for watching. Keep safe, keep fighting, and God bless us all.